So we've talked about groundwater and now surface water. Our last piece is to talk about ice. Okay, so in other words, glaciers. So glaciers are very powerful agents of erosion. These things are ice moving along. This is going to scrape the ground and move sediment along. Also, as it goes along, it's possible for some of that to get trapped within the ice, carrying all of that material. However, although they are really powerful agents of erosion, they're also very strong agents for deposition. Okay, once all of the ice melts, it deposits all of that stuff all in the same place, all in one go. So there are two types of glaciers. There are alpine glaciers, what we find in mountains, and continental glaciers. These are ones that actually span over continents. Continental glaciers are things like Antarctica. Okay, all of Antarctica is actually covered in this sheet of ice. Okay, we also have continental glaciers in Greenland. Okay, well, all glaciers are actually accumulations of snow and ice that have become thick enough and heavy enough that it actually moves under its own weight. Okay, so as the glacier builds up, once it becomes about 50 meters thick, the pressure from the overlying layers actually causes the entire mound of ice to begin to slide or flow plastically. Okay, so if you remember plastic, we talked about this with the interior of the Earth. It is still a solid, but it's able to flow and move under pressure. Okay, so because we have pressure of the material on top, the ice actually begins to slide plastically. Now, it's also possible to get some melt water underneath the glacier, which will actually lead to basal sliding. Okay, so we can have a little bit of sliding, but then we also have the flow, the plastic flow from the pressure of the overlying layers. Now, a glacier actually has two different zones. We have the zone of accumulation. Okay, accumulation is the region where snow and ice are forming faster than it's able to melt or sublimate. And then we have the zone of ablation. The zone of ablation is where it is melting and sublimating faster than it is growing. Okay, so we have the zone of accumulation where it's growing and the zone of ablation where it's actually shrinking. Now, alpine glaciers happen again within the mountains. Okay, so these occur within the Cascades, the Rockies, the Andes, and the Himalayas. Here in Utah, just by our mountains, there was the Timpanogos Glacier for a long time. I have not heard this from an official source, but I've heard it from a credible source that it's actually no longer considered a true glacier because there are actually times where it completely melts and goes away. Okay, but for a long time there was actually a glacier on the other side of Mount Timpanogos. Now, some things that glaciers do, some landforms they create, okay, they can produce cirque. Okay, so this is kind of an amphitheater-shaped region. Okay, they create an arete. Okay, that's these very sharp-edged regions along mountains. Okay, they can create horns. So this is actually an image of the Matterhorn, and it looks like a horn as we had glaciers on different sides moving along. Okay, this can also create what's called a hanging valley. Okay, so this is where we have a valley up much higher than the rest. So what likely happened here is we had one smaller glacier come and meet into a larger glacier. Okay, so we end up with this hanging valley. It will also produce U-shaped valleys. As the ice is coming through, it actually presses down on all sides, creating a U-shape. I actually really like this image here on the left because we can see that this valley started out as a U as it began to be carved and then changed into a V shape. What this tells us is that it started with a glacier pushing through, and then over time it warmed up, the glacier melted, and turned into a river, now cutting the V-shaped valley. Now, when glaciers melt, it drops all of the material all in one go. This is big bits, small bits, everything in between. Okay, so everything dumps all at once. So if you find a region that has very poorly sorted material, this is actually a region where a glacier melted. Now, this is very different from what we see from rivers, because as rivers slow, as they flow, they naturally slow down, and as they slow, different particles will fall out. Okay, so when it's going really fast, it's carrying everything. Then as it slows, it's first going to drop out the big pieces, the boulders and cobbles. And then as it continues to slow, then it's going to start allowing grains of sand and pebbles to fall out. And then eventually, when it really slows down, finally the silt and the very fine dirt particles finally settle out. Okay, so well-sorted sediment is actually a hallmark of rivers, whereas very poorly sorted sediment, where it's all of the stuff all jumbled together all at once, that's actually a hallmark of a glacier. Now, the last thing to talk about is wind. Okay, wind does actually lead to erosion and deposition. It's not nearly as strong as water. In fact, liquid water is the strongest form. Okay, so groundwater leads to caverns and sinkholes, which is pretty awesome. Glaciers, if there were lots and lots of great glaciers, they could actually do a lot, but right now there aren't that many glaciers on the Earth. We're in a warm period in the Earth's history. So right now it's actually water, liquid rainwater on the, or liquid water on the surface that is doing the most erosion and deposition. But air can actually do it. A great example of this is southern Utah. If you've ever been to Arches National Park, those arches were produced through wind action. Okay, now generally air blowing wind is actually a minor player. Okay, the regions where it has the strongest impact are where there are strong and frequent winds. Regions with sparse vegetation, this is because roots actually help hold particles together, and then the plant themselves helps to divert the wind from affecting the particles on the ground. Okay, and then also this will be have a strong impact in regions with small surface particles. Okay, so remember, to actually move stuff, we have to have greater energy, and wind is very low density, so it doesn't actually carry that much energy. So regions with small pieces will actually have the wind blow it around more. And so for the Earth, this is desert regions. Deserts are where the wind action is going to be the strongest. Okay, this is actually going to play a part when we start talking about Mars. Mars has all of these pieces, and so we'll actually see the wind, the effects of wind when we talk about Mars. Here is our fifth and final question. There are many erosive agents that sculpt Earth's surface. Overall, the erosive agent that does the most work is A, wind, B, groundwater, C, running water, or D, glaciers. Go ahead and think about it, and we'll discuss in just a little bit. All right, so the correct answer is C, running water. Okay, so wind does a little bit, but only in you have to have very specific circumstances. Okay, groundwater actually doesn't that much to erode, okay, meaning transport sediment. It travels through the material, and in some places it can dissolve, but overall it's not moving material that well. It's true that glaciers are very effective at erosion, but there just aren't that many glaciers today. So the best answer is actually C, running water from streams and rivers.